All right, y'all. I hope everybody's doing good today. We're getting ready for this Unit 2 test, and there are, I think, 12 questions on the test, and so I'm going over 12 problems. Here we go. You write what I write. That's my recommendation. Okay. Oh, let's fix that camera. Here we go. Unit 2 review. No, you cannot use this on the test. If you have questions as you are going through this review, please pause the video and ask, because that's what we're here for today. All right, first question. Let's say you have $400 saved, and you're going to save $25 each week for the next few weeks, okay? Now, you already know, because we've been working on linear functions, even if this was a question that we know nothing that we were going to have to do, everybody should know that the equation is y equals mx plus b. And for this situation, it'll be y equals, the rate of change is $25, because it's every week. That's the rate. And the initial value that they saved is $400. Now, the actual test question that we are actually studying is worded as such. All right, so you have $400 saved and $25. You're saving each $25 each week. The function that represents this is a sub n equals. All right, so a sub n equals 400 plus 25 n, and n is the weeks that she saves. A sub n is the amount of money in the account. So the question that they want us to answer is, how long will it take for her to have, let's say, $900? All right, so think about this. You want this table, X and Y. This is the weeks. Let me put the weeks. This is the money. The first week she had $400. Oh no, initially she had $400. The first week she had $425. The second week she had $450. So we're adding $25 every time. 25 is the common difference also. Keep that in mind. Okay, this is a sequence problem, and we need to find the nth term in the sequence, because we want that nth term to be $900. So the question is, when will this be 900? In other words, when will the entire function be equal to $900? You can work it like this equation, or you can go to Desmos and put this into the graphing calculator. N is the number of weeks. That's what we do not know. So let me show you Desmos. I come over here to Desmos and I type in y equals 400 plus 25x. And y'all, stop getting these variables mixed up. This is a coordinate plane. The coordinate plane has an x-axis and a y-axis. The only thing that you can use to represent variables are x and y. If the function is written as m of x, like, look right here. If it has like m of x equals some equation, you cannot type in m of x. You have to type it as y equals. I don't want to tell y'all that too many more times now. Alright, so over here on Desmos, here's the graph. I'm going to zoom out so we can see it. And they want to know when she will have $900. Go over here to the table, click the table. Now, look, this is kind of interesting because all we have is up to $450 for 2. What happens if we make this a 6? $550, 8, $675, 15 weeks, $755, 20 weeks, $900. So n will be equal to 20. And I use the table. You don't have to use the table. You can use this equation right here. We can go back to solving equations. 900 equals 400 plus 25N. She already has $400 in the account. So take away the $400 that she has. That leaves her with $500 that she needs to earn. And she's going to be putting in $25 each week. That means it is going to take her 20 weeks to have $900. So A sub n, when A sub n is 20, you get 900. So you should understand F of 20 is 900. Let's move on to question number 2. Okay, here we go for question number 2. On question number 2, they tell us that A sub 1 is 30 and A sub n equals A sub n minus 1 plus 6. And they want us to know, well, they want us to be able to find the function that we can use to find the nth term. We have talked about the nth term. We know we're doing sequences, so is this arithmetic or is this explicit? I mean, it's arithmetic, but is it recursive or explicit? To find the nth term, drum roll. Which formula are you going to use? Nth term, use explicit. So the explicit formula is on the formula sheet. Alright, let me see if I can find it on this wall over here. It's in orange, so it's so hard to see up there. Alright, so I think it says A sub n equals A sub 1 plus n minus 1 times d. That's what it says. Alright, Miss Cole say that's what it says. So our A sub 1 is 30 plus our n minus 1 stays as n minus 1. And D, the common difference. Big D in the house. Alright, I think the common difference is this 6. Adding 6 every time. Because the recursive says A sub n equals A sub n minus 1 plus D. Yeah, so this is D. D is a 6. Alright, now you know we got to clean it up. Can I just say something real quick? If you know A sub 1 is 30, and you know that the common difference is 6, then the previous term would have been, like it'd be 30, 36, 42. Well, what would the original term be, or the initial value? Because this is the first term, this is the second term, and this is the third term. So, if we can back up to the 0th, the 0th term. Alright, so we add 6 to move forward. Subtract 6 to go backwards and find the 0th term. I made that word up. The 0th term is the initial value in the equation y equals mx plus b. I've shown you this so many times. If you take 6 from that, you're going to get 24. So our initial value is 24. The rate of change is 6. So function notation should be f of n equals, what's the rate of change? M. What is m in this problem? 6. X plus b. What is b? It is the initial value, not the first value in the sequence. It's the initial value when x is at 0. It's the y-intercept. So that's going to be plus 24. Now, abracadabra, algebra just would not be fun if I did not show you the long way to get there. So you're going to take this one and you're going to clean it up. You're going to have 6 times n minus 1. Now, the only reason I put it in the front is because, I don't know, I'm old school. But remember I told y'all, if the 6 is negative, it needs to go in parentheses, especially if you're using decimals. So this is going to be 30 plus, distribute here, 6n, distribute there, minus 6. That's going to clean up to be 30 minus 6 plus 6n. So a sub n is going to be equal to, these two combined, 24 plus 6n. Look at that. The same equation. How did we get there? Well, we go back to middle school, right? I don't know what the initial value is, but I know that the first term is 30. I know that the common difference is 6, so the second term is 36. If I back up, I subtract 6, and the initial value is 24. So if you're going to use y equals mx plus b to get to the function notation, recognize that this is not the initial value. This is the first term in the sequence. All right, moving on. If you need to find the nth term in a sequence, you use the explicit, and you have to clean it up. Or understand that the first term is not the initial value, and that this rate of change is the common difference. I'm moving on. Call me if you need me, okay? Okay, question number 3. Question number 3 is, can you find the graph to this equation? Honey, let me tell you. Let's say, how about that? Let's talk about this question. The taxes is computed by taking 63 cents of the dollar and adding 4.3 to it. Oh, let me move this out of the way. This is the function. The question is, what does the graph of the function look like? As a matter of fact, first of all, this is a positive, right? So your line should be going up from left to right. Second thing, it intersects at 4.3 on the y-axis. So the line should probably intersect the y-axis somewhere around there. If you forget all of that, I done said this word so many times that I can't say it enough. Moving on to number 4. Put it in the calculator. Again, please. Do not type this as t of x. Type it as y equals. Call me if you need me. I'm moving on to number 4. Now, question number 4 is so loaded that if you don't understand the character of linear functions, bruh. But, okay, so here's what they're going to say. They're going to tell you, hey, find a graph that has at least one intercept at 0, 9. I sure hope you know where 0, 9 is on the graph. I'm going to tell you where it is. Here's 0, go up to 9. Now notice I'm actually writing down the information and plotting the information on the graph so that it'll help me. Alright, so number 4 says one intercept is at, it has at least one intercept at 0, 9, and it is positive. The graph itself is positive from negative infinity to 5. That means when the graph gets to 5 on the x, all about the x, no trouble. When it gets to 5 on the x, it becomes positive. Now, this won't work because at 5, from negative infinity up to 5, from negative infinity up to 5, the graph is in the positive area. So this will not work. Let me try another option. Alright, it did not say which intercept is at 0, 9. So, what if we take this and do 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's an intercept at 0, 9. And then from negative infinity to 5, it is positive. Oh, wait. That's right. Come back. Negative infinity to 5, it is positive. This is the graph. Oh, yeah. Look, this is from negative infinity. Here's negative infinity. All the way up to 5. The graph is up here on the positive side. That's correct. Nobody was here to correct me. I'm going to cry. All right. So, yeah, this is what the graph looks like. Because I just did the same thing over again, and I can't get to this intercept and be positive at 5 from negative infinity. Unless it did something like this and then went back up. But for the sake of the assessment, keep it simple. Let me say something about this graph. From 5 to positive infinity, the graph is negative. Because from here on down, it's in the negative side. From negative infinity to 5, the graph is positive. I think I want to make sure we understand negative and positive before we go to the next one. Alright, so look, here's a graph. And let's cross it right here. 1, 2, let's say at 3. Okay, from negative infinity to 3. So from here up to there, the graph is down here in the negative side. So if this was little Sally borrowing money from her uncle to start her barbering business, she borrowed money, so she's in debt, let's say $400, and every time she cuts some hair, she makes money. She got to cut 3 heads before she's out of debt. So from negative infinity to 3, the graph is negative. And then from 3 to positive infinity, the graph is positive. This is the positive side, and this is the negative side. Alright, moving on. Alright, question number 5. Question number 5 is dealing with domain and range. Where is the range of the domain? What is the range of the domain on a graph that looks real, that has real world context? Alright, so it's going to be positive, right? And let's say that each one of these are 50s. So this is 100, 200, 300, 1, 2, 3, 4, 5, 6. And we're going to start here, and we're going to stop. Alright, so now this point is 2, 100. This point is 5, 300. This is the X, this is the Y. This is the X, this is the Y. The domain values range from high to low, the X values. You go from 2 to 5. So given X, such that X, I need to write this in interval notation. So X, such that it is between 2 and 5. Okay. The range values, this is the range, the Y. The Y values are going from 100 to 300. So we put a Y in the center, put some ellipses around that thing now, and that's how we write it. If it had gone in both directions extensively, like this and that, then we would say from negative infinity to positive infinity for both the domain and the range. But since there were no arrows and it clearly ended, read your X and read your Y's, and then write the highest and the lowest as the domain and the range. Please write the order pairs down from the highest to the lowest so that you can clearly see, especially if you can't read from up to down and left to right. Right? Okay, because these are the domain values and these are the range values going this way. I'm expecting greatness, y'all. I'm expecting greatness. Question 6. Y'all remember when we talked about the tennis balls in the cans? I ran out of paper. So number 6, it had some tennis balls. It was like 3 balls in each can, and they could have up to 10 cans. Alright, so up to 10 cans and 3 balls in each can. Can we identify the domain, and the range. The number of balls, it really depends on how many cans there are. Depends on the number of cans. Alright, so I'm going to make a table like this. I'm going to call it X and Y. If you have no cans, you have no balls. If you have 1 can, you got 3 balls. If you got 2 cans, you got 6 balls. Never ever can we have 2.5 balls. And in this case, we cannot have 5 balls because it's in increments of 3. So our domain values versus our range values, if it's up to 10 cans, this is the cans. So the domain values are going to go from 0 to 10 with those values included. The range, they are very particular on 0, 3, 6, 9, 12. And if you go up to 10, the last range value you can have is 30. Alright? Just want to put that out there. As I was looking, I'm not going to talk about number 7, because if you can understand number 1, you'll be fine for number 7. Let's say that we're on question number 8 right now. For problem number 8, let's say, CFA 3. This is a linear function. This is a non-linear 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 function. And this is a non-linear function. This is linear. All of these are none. This is an absolute value function. No, this is a quadratic, okay? Quadratic, which is y equals x squared. This is absolute, which is y equals the absolute value of x. This is like exponential growth or exponential decay. So y equals e to the x. This is cube root. Y equals x cube root. The cube root of x, I think, or x to the third. It's a cube root. And this is a square root. Y equals the square root of x. I don't know how to tell y'all to remember this, but the u is in quadratic. The v is in absolute value. The curve is in the e. The little squiggly, that's a 3. And then the square root symbol right here tells you, hey, just woo, run away with it. Own it. Make it your own. Alright, moving on. Alright, I went to the gas station. I bought some gas. The function for it was something like, I don't know, what was it, Brian? Y equals, it was $3.99 fee, and then the gas was probably about $3.69 a gallon. I remember it was expensive. What are we doing with this problem? We need to talk about the graph is going to look like $3.99 is the initial fee, and then it's going to increase, and I can only hold 12 gallons of gas. Alright, keep that in mind. Alright, so the domain and the range. This is the cost. This is the gallons. This is the y-intercept. This is the x-intercept. This is how much it costs initially. If you have a graph that comes this way versus this way, this is your x-intercept. If this is the number of shirts, then that means if you get 6 shirts, you can get no shoes. If you get 6 shoes, you can get no shirts, because this order pair is 5, 0. This order pair is 0, 5. Two different things. Make sure you know what the intercepts represent. Alright, last question. If this is a gas station problem, right, what does f of 0 equals 0 means? And what does f of 12 equals 5693 means? In the context of this problem, this is about cost in a gallon of gas. I tell you what it means. If x is 0, that means if you don't get any gas, then y? You don't pay any money. This one means if you get 12 gallons of gas, cost, then you pay $56.93. Be able to interpret notation function like f of 1 equals 6. This is x, this is y. F of x is y because y is a function of x. Happy testing.